Welcome to an introduction to limits. The first type we're going to look at is where the limit approaches some constant c for a given function f of x. Now, what this tells us is that we are going to substitute values for x into the function, and those values are going to approach a certain constant c. That means that those x values are going to get closer and closer to c, which is going to cause our function to behave in a certain way. Meaning that as x approaches c, the function itself is going to approach a certain value as well. So we're trying to figure out what exactly is that value. To understand this better, let's look at an example. Say that we are given the limit as x approaches 2, and let's say that the function we have is x squared minus 9 over x minus 3. So we're going to substitute x values into this function, and we'll look at what happens to the y values as our x values approaches 2. Okay, let's say that we've got x values on the left-hand side and we have our function on the right-hand side. Now, you're welcome to start at whatever x value that's smaller than 2. I want to choose something that is closer to 2 so that we're able to identify the pattern a lot easier. So I'm going to go with 1.9. Now we're going to take 1.9 and we're going to substitute into our function, and notice what happens to our y value. Once we substitute, you're going to end up with 4.9. Let's try another value. Let's try 1.99. Also notice that we are approaching 2, so each time an x value that we substitute is going to get bigger so that it gets closer to 2. Now, substituting 1.99 into the function gives us 4.99. Okay, next, let's try 1.999. And substituting into our function gives us 4.999. So notice that on the left-hand side, as our x values are getting bigger and bigger and they're getting closer to 2, our y values are actually getting closer to 5. So eventually, if we had to substitute 2 for x, you will notice that the y value is 5. This is what the idea of a limit is. It tells us that as our x values approaches a certain constant, our y values are also going to approach a certain constant. And the constant that the y values approaches is what we are trying to calculate. That is what we are concerned with. Okay, so we are not going to use a table, but rather we are going to look at a method of evaluating the limit itself. So we're going to look at steps of how to simplify this and how to use the limit so that we can get to that answer. Now, the first step when it comes to limits is to simplify whatever equation you have. So if you look at your numerator, it is in the format of difference of 2 squares. That can be factorized. So generally speaking, we try to factorize wherever possible. Okay, so let's just make a note of that. Our first step is to factorize. And once you're factorizing and once you're simplifying, you still keep the limit. The limit will be omitted only once you use it. So in the numerator, for difference of 2 squares, we are going to open up 2 brackets. It will be x plus 3 and x minus 3. The denominator cannot be factorized at the moment, so that's fine. Now you're going to notice that we have x minus 3 in our numerator and our denominator as well. So those two can actually cancel out with each other. Now what we're left with is just x plus 3. So once you've factorized and simplified, you can now make use of the limit. And it is only at this step, when you make use of the limit, that you omit the limit on the left-hand side. So we are taking this x approaching 2, and we are going to substitute it in place of x. So we're going to have 2 plus 3, and that gives us an answer of 5. So that tells us that as x approaches 2 for this given function, our y values will approach 5. And this is evident in the working out that we've done on the right-hand side. We can clearly see that as our x values get bigger and bigger, and as they approach 2, our y values also get bigger and bigger, and they approach 5. Okay, let's look at proper example. Let's call this example 1. Say we have the limit as x approaches -1 of x cubed plus 1 all over negative x squared plus x plus 2. Now, we said that whatever question we're given, whatever function we have, our first step is to factorize wherever possible. If you look at your numerator, x cubed plus 1, that is in the format of the sum of 2 cubes. If you look at the denominator, that is a quadratic trinomial. So in this question, both the numerator and denominator can be factorized. Since we are going to factorize and simplify, we are going to keep the limit on the left-hand side because we're not exactly making use of it yet. Okay, factorizing the numerator for sum of 2 cubes, we know that it results in a binomial and a trinomial. That is going to be x plus 1, and the trinomial is going to be x squared minus x plus 1. In the denominator, we've got a quadratic format. However, because we have this negative in front, I'm first going to factorize. So let's pull out that negative as a common factor, and that just makes it a lot easier for us when we're about to factorize. Okay, so at the moment, the numerator is going to stay as is. And let's factorize our denominator. So that is going to give us x plus 1 and x minus 2. Now at this point, you will notice that you've got x plus 1 at the top, x plus 1 at the bottom. They cancel out with each other. So before we make use of the limit, let's first just write down what we have so it's clearer for us to see. In our numerator, we have x squared minus x plus 1. In our denominator, we can actually take this negative and multiply it back into the bracket. So we're going to have minus x plus 2. Now that this cannot be further simplified, we can make use of our limit. So we are going to take this negative 1 and substitute in place of x. That's going to be negative 1 all squared minus negative 1 plus 1 And in our denominator, we're going to have a negative into negative 1 plus 2. So if we simplify the numerator, we're going to get 3. So negative 1 squared is 1, 1 plus 1 plus 1, that gives us 3. In the denominator, negative times negative 1 gives us positive 1. Positive 1 plus 2 gives us 3. So we have 3 over 3, and that is going to equal to 1. So this is our final answer. So to add on to our steps, our first step is to factorize. Our second step is to simplify. When we say simplify, we mean once we've factorized, if we have any common brackets in our numerator and denominator, they can cancel out with each other. Okay, so our aim of factorizing is to find common brackets that can be cancelled out. And the last step after we simplify is to make use of the limit. And when I say make use of the limit, that is the step where we now take the value that was our limit and substitute wherever we had x in our function. And then once we do that, we just have to simplify and get our answer. Okay, let's look at another example. For example 2, we have the limit as x approaches negative 3 as x approaches negative 3 of x plus 3 all over x squared plus 4x plus 3. So our first step is to factorize. The numerator cannot be factorized, but the denominator is in the format of a quadratic trinomial. So denominator can be factorized. Remember, while you are doing your first two steps, you keep the limit. You only leave the limit out once you use it. Okay, so the numerator will stay as x plus 3. The denominator, however, we are going to factorize. When you factorize a trinomial, it results in two binomials. So we're going to have x and x. Remember how to factorize a trinomial? You look at factors of the last term. When they multiply, they must give you the last term. But when you add them, they must give you the middle term. So 3 is a prime number. Factors of 3 would be 1 and 3. Since we need a positive 3, we need to use positive 1 and positive 3. Could be negative and negative, but once we add them, we need to get the middle term. So it's going to be a positive 1 plus 3, which will give us plus 4. Now, like I mentioned in the previous example, the aim of factorizing in your limit questions is so that you can cancel out any common brackets from the numerator and denominator, which we do have here. We've got x plus 3 in the numerator as well as x plus 3 in the denominator. So now we're done with the first two steps. Before we make use of the limit, I just want to write down what we have left. In our numerator, we have 1. In our denominator, we're left with x plus 1. Now we can make use of step 3. So we are going to make use of the limit. So we are now going to take we're now going to take this -3 and substitute it into x. So we're going to have 1 over -3 plus 1, and -3 plus 1 is -2. So that is our final answer. This tells us that for this function, as x approaches -3, the function itself approaches -12. Let's look at one more example. Okay, we have the limit as x approaches 0, and the function is 5x cubed plus 8x squared all over 3x to the power 4 minus 16x squared. Right, so our first step is to factorize. Now, we do not notice any particular format for the numerators and denominators. However, our terms do have common factors within themselves. So if we look at the numerator, we've got x squared that is common, and in the denominator as well. So let's start off by making use of step 1, which is factorize. We're going to pull out that x squared as a common factor, and in our first term, we are left with 5x plus 8. In the denominator, we're also going to pull out x squared. In the first term, we are left with 3x squared minus 16. Now, once we've factorized, we notice that we've got x squared in the numerator, x squared in the denominator. They can cancel out with each other. So by cancelling out, you are simplifying, and we are now ready to make use of the limit. That tells us that as x approaches 0, we have the function approaching a certain value, and we want to figure out what is that value. So we're now going to make use of the limit, which means that we are going to omit this lim on the left-hand side. So we're going to have 5 into 0 plus 8 all over 3 into 0 squared minus 16. Simplifying the numerator, 5 times 0 is 0, 0 plus 8 is 8. In the denominator, we've got 0 squared, which is 0. 3 times 0 is 0. 0 minus 16 is negative 16. This can be simplified, and we are going to get negative 1 over 2 as our answer.